Welcome to another episode of Nathan Builds Robots. Today I'm excited to review the Ender 3 V3 SE. This might very well be the most important 3D printer to come out in the last 2 years, so let's check it out. And the reason why this printer is so important is because it's an Ender 3. Ender 3s are just a great entry point into the market for a lot of people, and they have an amazing community of modders built around them, so it's always fun to see what people are coming up with in terms of Ender 3 mods. I mean, that's how my channel got started. Also, there's been a trend of 3D printers getting more and more expensive, but this printer is coming in at an extremely affordable $200 to $220. So that's undercutting the cost of a lot of the other Ender 3s and Ender 3 clones on the market, while being smaller and lighter and bringing a bunch of new features. So this is a really exciting printer from Creality. As I hinted at in my preview video, they've used a different type of aluminum extrusion here. This is actually a huge deal. We've been using the same standardized aluminum extrusion for quite some time, and everybody's just like, yeah, I guess that's just how we build these things. But Creality has went back to the drawing board and they've designed a new profile that promises to be lighter and more efficient. And you can see this whole thing is a little bit slimmer and more compact thanks to this design choice. So let's just put these together. I guess this just goes right here. Then we've just got 3 screws to install into the bottom of the machine. So let's just get those put together. And it looks like up here they're actually using a 26-pin connector instead of the old 24-pin connector. So my modder boards won't be compatible with this new printer. But we can plug it in just like this, and now you can see this will slide back and forth just fine. We've got our Z-axis moving up and down, then we've got our Y-axis going back and forth just like this. So it looks like everything's all put together and ready to rock. So let's turn this thing on. They provide an extra nozzle and a little strain relief bracket that you can install up here that just holds on to that wire. And then we'll plug our little motors in here and we're all set. Now it looks like, oh, that's very interesting. So they have 2 extra wires on the print head. They're using a 26-pin cable instead of a 24-pin cable. And the reason they did that is because they've actually relocated the X-axis limit switch onto the print head itself, which makes sense because it reduces the amount of wiring that you have to do outside of the hot end, plus it just focuses all of your sensors and stuff onto this hot end itself. It would have been even better to see sensorless homing, but given the price point of this machine, I'm sure they had to make some compromises there. So we've got our limit switch homing, which is fine. It's also going to be more reliable than other methods of homing, so when you're producing millions of 3D printers, you want them to be as reliable as possible. Then we've got our screen that will attach onto the side here. Looks like it's going to take 3 screws to attach that. Then the last little bit I'm going to install is the spool holder up top. Then I've got 2 leftover screws. I'm not exactly sure where they go yet, but I'm sure we'll figure it out. And I'm just going to load up this included sample of filament, and we should be good to go here. So altogether, the setup of this machine took about 10 minutes. It was very easy to do. Everything seems properly tensioned. All the wheels are nice and tight. I really like this setup with the compact V-groove wheels on the Z-axis and the use of a single stepper motor that's synchronized with a belt here. This really seems like it's going to be a worthy successor to the Ender 3. The Ender 3 S1 was kind of going up budget compared to the older Ender 3 models. This one is going rock bottom prices with good build quality and a new, more innovative design. So I really like what I'm seeing here. Let's go over all the features from the outside. So it looks like we've got an injection molded plastic base. There's a sheet metal steel bottom cover here. And it looks like they actually put some little features in there to stiffen up this bottom panel. So hopefully it won't be amplifying those vibrations as much as on other 3D printers. It's got a thicker stamped sheet metal part that looks like it connects the bottom here over to this side. So that's just stiffening up that frame. We'll take a look at the main board and the power supply in a future video. I know everyone's excited to learn everything about this machine, but we're just going to gloss over that little detail and look at some of the other features on the outside of this machine, just because there's so much new stuff to cover. So it looks like on the Y-axis, we've got dual linear rods. So these are just stainless steel rods with linear bearings on there. Those are linear ball bearings. They've done away with the bed leveling knobs, so you're not going to have to go in here and manually level things. They've just got solid steel spacers, or I guess they're nylon spacers by the look of things. One really notable feature is that they've got a load cell installed into the bottom right here, and that load cell is going to be used for calculating the Z offset automatically. So it's going to be able to build up a bed leveling mesh using this CR Touch. It's still surprising to see it on such a low budget entry into the market, having that automatic bed leveling probe. But on top of that, they're doing an automatic Z offset. So I assume it's just going to mesh this whole thing using the CR Touch, and then it's going to come down here and touch the bed with the nozzle, and it'll be able to sense that contact using the load cell. So it knows exactly when the nozzle is touching the bed, and you're not going to have to program in that Z offset by yourself. That was a manual step that new users found particularly challenging, but they've gotten rid of that on this machine and they've just automated it. So it should be a better user experience for new users. Unfortunately, it's not using a PEI build sheet, it's using one of these polycarbonate ones. The polycarbonate build sheet works really well. It's not too much of an issue. I've just occasionally had issues where prints will stick too well to it and it'll cause problems. Hopefully with that automatic offset calculation using the load cell, it'll be more consistent and it won't over attach to the build tray. But we'll see how that works out soon enough. This more compact aluminum extrusion is really interesting. So it looks like it's like a 1x1 aluminum extrusion on the back here, and then they've got a solid flat face attached to the front to just help stiffen everything up and make it look better. I think they did a great job with this machine. The top is injection molded, and then we've got our spool holder up top. Then along the back we've got a single stepper motor for controlling the Z-axis height, and it's synchronized with a belt up top here. This belt tension is nice and tight, that's what we like to see. And on the second Z-axis lead screw, there's no stepper motor. It's just driven by this belt up top, which helps them reduce the number of stepper motors required to build this thing, ultimately driving the price down. Oh, I see where those last two screws go. There's two screws that go in right there, so let me just install those. I really like the compact setup for these little wheels. It helps make everything more compact, and that ties into some of the changes that they've done to the X-axis gantry. You can see the stepper motor, You can see the stepper motor is right here instead of hanging off to the side like it has been on a lot of other Ender 3s and Ender 3 clones. Tucking it into this little unused space helps make everything more compact. It makes this thing a little bit slimmer on your desk and also saves room in packaging. The box this came in is one of the smallest boxes that I've ever received a 3D printer in. And it's also a pre-assembled machine, so the magic that they've done with the packaging on this thing is really impressive. Then we've got a little screen here, and by little, I do mean little. This is a very small screen. Let's just peel that plastic off, and we'll see how that user interface goes. So a lot of really innovative stuff here. I really like what I'm seeing so far. Let's get this thing fired up and see how well it prints. But before we do that, let's just take one little peek under the hood. I want to see what's going on with this Hotend. They kind of went with this newer medieval armor styling on the base of the machine and on the Hotend itself. So let's just take off the plastic cover and see what's going on under here, because I am curious about that. Alright, so here we have the Sprite extruder. The breakout board looks like a completely new design, so if I'm going to make a modder board for this thing, I'm probably going to have to go back to the drawing board and figure out how to make a new version of that. So let me know in the comments below if you think I should make a new version of the modder board. You can see there's a bunch of extra connectors in here. Unfortunately, they're using the same tiny little Pico blade connectors. Not my favorite design overall. It looks like they're using an absolutely massive heat sink and then a little fan attached to it. So you're definitely not going to have any heat creep issues on this machine. And the other potentially disappointing bit of news here is it looks like they're using, a PTFE lined Hotend. You can see inside of here the heat break is a little bit too thick to be an all metal Hotend, so there's probably some kind of PTFE lining in there. And that's just more noob friendly. It lets you mess things up and not damage things so much. However, it limits you to printing with PLA and PETG. So not my favorite choice there. And then on this large shroud, it looks like we're using a 24 volt 100 milliamp, and this is a 40 by 10 blower fan. So I was really hoping they stepped up the part cooling on this printer, and it even looks like they're using a 3D printed shroud. So it's going to be interesting to see what other people can come up with. One of the cheapest and easiest ways to upgrade a 3D printer is to put a better part cooling fan on there, because that just helps you with print quality in general. So I think it'll be interesting to see what people can come up with in terms of adding a new fan duct design onto this thing. So it's still an Ender 3, and it's not perfect out of the box, and you might need to do a little bit of modding to get the most out of it. But overall, this looks like a very nice design, and I'm sure it's going to print wonderfully. The closest thing to this design would be the Ender 3 S1, which was retailing for around $300 last I checked. So with Creality releasing this printer, having it with a lower price with more features is really going to cannibalize those Ender 3 S1 sales. So it's going to be interesting to see how all that plays out. But one thing is for sure is that this is probably going to be one of the best deals on the market moving forward. I think there's definitely some room for improvement on this hot end. I would probably like to put an upgraded part cooling fan on here, as well as a different hot end and heat break combination. I really like the Sprite extruder. I've been able to push insane flow rates out of these things, so I'll probably leave the Sprite extruder on there, just because it's faster than a lot of the more expensive extruder upgrades on the market. A lot of extruder upgrades focus on being lightweight and all that, but the Sprite hot end is just designed to be chunky and strong, and it does a great job of pushing high flow rates and just being a reliable extruder for my purposes. So let's get this all put back together, and we'll fire this thing up and see how it prints. Everything seems to fire up just fine. The interesting thing is that these blocks on the left and right side of the X-axis gantry are injection molded plastic. So you'd probably be able to 3D print your own versions of these out if you wanted to do some crazy mods. But for now, I think it's just going to work fine the way it is. This seems like a really nice design, so let's just put it through its paces. So for setup, we're going to set it to English, and we're ready to print right away. There's no cloud setup, there's no account creation or Wi-Fi attachment. Like, this is just a bare bones printer that you should be able to get up and running pretty much instantly as soon as you get it built. We'll plug in our little SD card here. And one thing to note, it's using a full-sized SD card, so we can plug that in just like this. And then we've got a USB-C port. I assume you can plug in some kind of removable media like a USB flash drive into that port, or maybe plug in like an Octoprint or something to send G-code over that port. I'm not sure exactly what you can do with that, but it's good to see those connectivity options. If you look at the side profile of this thing, it's actually quite slim front to back as well. On a lot of the Ender 3s and Ender 3 clones, they have the Y-axis stepper motor just hanging off the back here, and they've got a bunch of extra stuff coming out the front, like the belt tensioning knobs and stuff. On this Ender 3 V3 SE, they've made sure to compact everything as much as possible. So one of the most interesting new features on this machine is going to be that automatic Z-axis offset. So let's go through our bed leveling options. Well, one thing I'm noticing right away is this isn't a touch screen. It's this wheelie knob screen, but they're actually using a quite high quality LCD panel, so I've got great viewing angles on this thing. I know on some of the older 3D printers, if you look at it off axis by like 10 degrees, it starts changing colors and it's hard to read things. But this is a very nice LCD panel. It's a little bit smaller, but it's a very high quality panel that's easy to read. So let's go to leveling. So it's just going to go through all of that leveling automatically. I mean, normally it brings up this sub-menu with all these options, and you have to be like a 3D printer expert to figure out how to do it. But this one, you just go to bed leveling, and it looks like it's going to do it all automatically. So right now it's deployed the bed leveling probe. It's going to go ahead and touch the bed. And then I'm really curious how it uses this load cell. So let's get some close-ups on that as it's happening. All right, so now we've got a great view underneath this machine. You can see there's no bed leveling springs or knobs down here for you to mess around with. This is supposed to be a super easy experience where you're not having to go through and do things manually. So we'll see how this works. Right now the nozzle is heating up, and overall this is a pretty quiet machine. It's making a little bit of noise, but it's really not that bad. All right, so the nozzle is still heating up, but I don't have any readout as to the nozzle temperature. So I'm just trusting that everything is going according to plan. We'll do some audio tests here, so we'll put the mic up next to the printer and you can listen to it. Alright, so now it's doing the nozzle cleaning operation, so I'm not sure what that entails exactly, but we're about to find out. Alright, so that's the Auto Z offset calibration. It just goes and uses the BL touch, and that calculates a certain Z height, and then it goes and touches the nozzle to the bed, which calculates a different Z height, and the difference between those two numbers is your Z offset, and that should be much more accurate than a manual calibration. Alright, it looks like our bed leveling just finished up. If we take a look at the mesh that it generated, the values are ranging from negative 0.53 to positive 0.7. So overall, that's a pretty flat bed. It looks like the front left corner here is elevated a little bit high and the back right is a little bit low. But overall, it's pretty flat, and we should be able to get good results off of it, especially since it's created that automatic bed leveling mesh, and it should be adapting to that first layer being a little crooked. Everything's going to come out just fine. So let's hit confirm. This is like really nice and snappy firmware. I don't know if this is a new version of Clipper, but everything here looks really nice. If we go into our motion settings, it looks like we can set our max accelerations. It looks like the default values are 4,000. So that's going to be a pretty fast machine, and our max speeds are set to 500 millimeters per second. So this is going to be quite a speedy little machine here. I'm excited to put it through its paces. Looks like we've got one print job on here called Cat, so let's just fire that up and see what we get. I'll hit confirm, and now that's going to heat everything up and get the print started. So let's see how this turns out. Now, if this printer doesn't deliver excellent print quality, then there's not going to be much of a place for it in the market, because that's just a given. Every printer has to have amazing print quality these days. Overall, I really like how Creality went back to the drawing board and just kind of re-optimized this design and improved a bunch of various aspects of it. This has almost no parts in common with the old Ender 3S1, other than the extruder. Maybe it's using some of the same stepper motors, but everything's been just kind of reconfigured a little bit and optimized to be cheaper, nicer looking, and more efficient. So let's see how it goes. While this print is getting started, I'll do some sound tests. So I'm just going to use my decibel meter app. I go an arm's length away and we'll measure the sound levels. So it looks like at idle with the part cooling fan off and the hot end cooling fan on, we're looking at like 42 to 43 decibels, which is pretty quiet when all is said and done. All right, and we've got our first print going. I didn't have to do any manual bed leveling at all. I just put it together and hit go, and we'll see how this turns out. And you can see what I mean about this screen. I'm viewing this at an off angle, and we've got excellent colors and contrast. So this is a much better screen than we see on most 3D printers, and especially on a budget entry-level machine like this, that's really nice to see. So let's just let this print go. It's just going to do its thing. First layer looks like it's going down pretty well, but you know, we'll have to see how it turns out. Once we start the second layer, it should ramp up in speed a little bit, so it'll be exciting to see how fast this printer can go. It looks like the acceleration and speeds are quite good on this machine, but I know how these sprite hot ends work. It can go faster than this. I'll try turning it up in a little minute here, but overall, this looks like excellent print quality at a very good speed. So, you know, this is awesome that entry-level printers are getting this good. This is quite fast and impressive, but I'm going to see if we can turn the speed up even more. So I'm going to go to printing speed. We'll set that to 150%. And it's keeping up just fine. This is impressive to see. Let's turn it up to 200%. Just listen to this thing in action. The part cooling fan is a little bit loud, and it does make a little bit of mechanical noise from the print head moving back and forth, but overall it's really not too bad. I've heard much worse. Let's turn the print speed up to 300%. Even at this 300% print speed, it's coming out quite nice, but I think if you want great quality, you won't want to push it too much faster than 200%. Let's get you some close-ups so you can see what's going on here. Alright, so this is the standard print profile running at 200% print speed. It's probably acceleration limited for a lot of these moves to 4,000 millimeters per second squared, which is still not a small amount of acceleration. I mean, Bambu Lab printers are known for being quite fast, but even those will typically only be printing between 2,500 and 5,000 millimeters per second squared. So the fact that this cheap entry-level budget bed slinger can go up to 4,000 millimeters per second squared is actually extremely impressive. And if we take a look at our little control screen here, you can see that Z offset was automatically calculated. It's set to negative 2.32. I did not set that up. That just automatically calculated itself, and it's running with that. And it looks like it's doing a great job. So that's a super nice and convenient features for beginners and experts alike. I'm going to do another decibel reading an arm's length away again, and we'll look at my little meter here. So it looks like it's varying between 50 and 57 decibels. And that's just depending on whether it's making those travel moves, which make a little bit of a scratchy noise that can elevate those decibel readings. But at the baseline, it's only about 50 decibels even with this part cooling fan on. And when those linear bearings are making some noise, it's really only going up to about 57 in short peaks. So overall, it's a really nice and quiet machine, and we'll just let you listen to it while it finishes up this print. Testing. All right, so that wraps up our first print. Let's see how it did. That first layer came out really nice thanks to that automatic Z offset detection. And you can see there's a couple issues here because this tangled filament thing was not printing very well. I don't know why they still bother sending you this kind of filament with a brand new 3D printer. I guess it's forgivable given the price point of this machine. But overall, I'm not seeing a whole lot of issues with this print. It looks like there's some cat hair texture baked into this model. Overall, pretty nice. There's a little bit of under extrusion there because it got caught and stopped printing for a minute. So that was a weak layer. So I think this printer delivers what it promised. It's a cheap Ender 3 style printer with a lot of design improvements to just make everything more streamlined and more premium feeling. The thing that's really crazy about this printer is it's got a nicer LCD screen than what you get on the Bambu Lab P1P and P1S. Despite that being a $600, $700 printer, on this you get a pretty decent LCD screen. Just, a good printer overall, decently fast. As I said before, there's still some room for improvement on this machine. There's some changes to the hot end and the part cooling fan that I could see as adding a little bit of value to this printer. But overall, it's an incredibly competent package immediately out of the box. Given the numbers that I'm seeing on this machine, I would imagine a Benchy will print out in about 25 minutes. So, pretty fast printer. Not the fastest in the world, but really good for an entry-level machine, especially one that requires as little setup as this one does. And if I were setting up a print farm today, and I was printing mostly PLA or PETG parts, I would definitely consider this as the top of my list in terms of 3D printers I would want to buy up for a print farm. Because it's so inexpensive, you can start up so many print jobs and get everything running super easily. There's very minimal tuning and setup that you need to do for each machine. So it's just going to be a great machine if you need to buy multiple printers or if you just want a cheap entry-level printer and you're curious about the 3D printing hobby. Alright, so thanks for watching this episode of Nathan Builds Robots. This was just kind of a first look at this Creality Ender 3 V3 SE. I'm pretty excited about it, and we'll do a deeper dive into it in a future video. We'll really tear this thing apart and run some more print tests. But for now, it delivers what it's supposed to, and at face value, it appears to be a great machine. So, thanks for watching, and I'll see you in the next video. Also, keep in mind that Creality sent this machine over to me to review. I didn't have to buy this machine, but, you know, I don't need another bed slinger. I'm just giving you my honest opinions about whether or not I think this is a good machine. And overall, it seems to deliver, and it looks pretty nice. So that is my opinion on this matter. Remember to subscribe, like the video, and I'll see you in the next episode. Oh, it looks like they ran some TPU through this machine to test it before sending it out. So this is a stretchy filament. It's like very stretchy. So being able to print flexibles on this would be pretty nice too. Well, I guess there's not a whole lot more to talk about with this machine. In the next video, I'll really tear this thing apart and do some more in-depth analysis. But for now, it looks like it's delivering what it promises, and at face value, it appears to be a great printer for beginners, people that want to set up a print farm, or, you know, let's just say you want an extra printer that you want to mod. This is a really cheap entry-level machine that you'll be able to take parts off of it and change things around pretty easily. The only downside I can see to the modders is going to be this proprietary breakout board that's using tiny little connectors. I solved that problem on previous versions of the Ender 3 using my modder board, but on this one it's not going to be compatible. So it looks like I'm going to have to go back to the drawing board for the modder board and come out with a new version of that.